Feathers are one of the most recognizable characteristics of modern birds, and a trait that was also shared by several non-avian dinosaurs. Based on the current distribution of fossil evidence, it appears that feathers were an ancestral dinosaurian trait, though one that may have been selectively lost in some species. 249 direct fossil evidence of feathers or feather-like structures has been discovered in a diverse array of species in many non-avian dinosaur groups, 70 both among saurischians and ornithischians. Simple, branched, feather-like structures are known from heterodontosaurids, primitive neornithischians, 250 and theropods, 251 and primitive ceratopsians. Evidence for true, veined feathers similar to the flight feathers of modern birds has been found only in the theropod subgroup Maniraptora, which includes oviraptorosaurs, troodontids, dromaeosaurids, and birds. 250 feather-like structures known as pycnofibers have also been found in pterosaurs. 253. However, researchers do not agree regarding whether these structures share a common origin between lineages, i.e., they are homologous, 250-255, or if they were the result of widespread experimentation with skin coverings among ornithodonts. 256. If the former is the case, filaments may have been common in the ornithodon lineage and evolved before the appearance of dinosaurs themselves. 249. Research into the genetics of American alligators has revealed that crocodilian skuts do possess feather keratins during embryonic development, but these keratins are not expressed by the animals before hatching. 257. The description of feathered dinosaurs has not been without controversy in general. Perhaps the most vocal critics have been Alan Feducia and Thea-Garten Lingham-Solier, who have proposed that some purported feather-like fossils are the result of the decomposition of collagenous fiber that underlaid the dinosaur's skin. 258. 259. 260. And that Maniraptoran dinosaurs with veined feathers were not actually dinosaurs but convergent with dinosaurs. 248. 259. However, their views have for the most part not been accepted by other researchers, to the point that the scientific nature of Feducia's proposals has been questioned. 261. Archaeopteryx was the first fossil found that revealed a potential connection between dinosaurs and birds. It is considered a transitional fossil, in that it displays features of both groups. Brought to light just 2 years after Charles Darwin's seminal On the Origin of Species, 1859, its discovery spurred the nascent debate between proponents of evolutionary biology and creationism. This early bird is so dinosaur-like that, without a clear impression of feathers in the surrounding rock, at least one specimen was mistaken for the small theropod Compsognathus. 262. Since the 1990s, a number of additional feathered dinosaurs have been found, providing even stronger evidence of the close relationship between dinosaurs and modern birds. Many of these specimens were unearthed in the Lagerstätten of the G-hole biota. 255. If feather-like structures were indeed widely present among non-avian dinosaurs, the lack of abundant fossil evidence for them may be due to the fact that delicate features like skin and feathers are seldom preserved by fossilization and thus often absent from the fossil record. 263. Skeleton. Because feathers are often associated with birds, feathered dinosaurs are often touted as the missing link between birds and dinosaurs. However, the multiple skeletal features also shared by the two groups represent another important line of evidence for paleontologists. Areas of the skeleton with important similarities include the neck, pubis, wrist, semilunate carpal, arm and pectoral girdle, furcula, wishbone, and breastbone. Comparison of bird and dinosaur skeletons through cladistic analysis strengthens the case for the link. 264. Soft anatomy. Pneumatophores on the left ilium of Arastean rhyocoloridensis. Large meat-eating dinosaurs had a complex system of air sacs similar to those found in modern birds, according to a 2005 investigation led by Patrick M. O'Connor. The lungs of theropod dinosaurs, carnivores that walked on 2 legs and had bird-like feet, likely pumped air into hollow sacs in their skeletons, as is the case in birds. What was once formerly considered unique to birds was present in some form in the ancestors of birds, O'Connor said. 265-266. In 2008, scientists described Arastean rhyocoloridensis, the skeleton of which supplies the strongest evidence to date of a dinosaur with a bird-like breathing system. CT scanning of Arastean's fossil bones revealed evidence for the existence of air sacs within the animal's body cavity. 226. 267. Behavioral evidence. Fossils of the trudonts and cynornithoids demonstrate that some dinosaurs slept with their heads tucked under their arms. 268 This behavior, which may have helped to keep the head warm, is also characteristic of modern birds. Several Deinonychosaur and Oviraptorosaur specimens have also been found preserved on top of their nests, likely brooding in a bird-like manner. 269 The ratio between egg volume and body mass of adults among these dinosaurs suggests that the eggs were primarily brooded by the male, and that the young were highly precocial, similar to many modern ground-dwelling birds. 270 Some dinosaurs are known to have used gizzard stones like modern birds. These stones are swallowed by animals to aid digestion and break down food in hard fibers once they enter the stomach. When found in association with fossils, gizzard stones are called gastroliths. 271 Extinction of major groups. Main article. Cretaceous-Paleogene extinction event. All non-avian dinosaurs and most lineages of birds. 272 became extinct in a mass extinction event, called the Cretaceous-Paleogene (KP) extinction event, at the end of the Cretaceous period. Above the Cretaceous-Paleogene boundary, which has been dated to 66.038 plus or minus 0.025 million years ago, 273 fossils of non-avian dinosaurs disappear abruptly. The absence of dinosaur fossils was historically used to assign rocks to the ensuing Cenozoic. The nature of the event that caused this mass extinction has been extensively studied since the 1970s, leading to the development of two mechanisms that are thought to have played major roles: an extraterrestrial impact event in the Yucatan Peninsula, along with flood basalt volcanism in India. However, the specific mechanisms of the extinction event and the extent of its effects on dinosaurs are still areas of ongoing research. 274 Alongside dinosaurs, many other groups of animals became extinct. Pterosaurs, marine reptiles such as mosasaurs and plesiosaurs, several groups of mammals, ammonites, nautilus-like mollusks, rudists, reef-building bivalves, and various groups of marine plankton. 275. 276 in all. Approximately 47% of genera and 76% of species on Earth became extinct during the KPG extinction event. 277 The relatively large size of most dinosaurs and the low diversity of small-bodied dinosaur species at the end of the Cretaceous may have contributed to their extinction. Wink with a frown. 278 The extinction of the bird lineages that did not survive may also have been caused by a dependence on forest habitats or a lack of adaptations to eating seeds for survival. 279 280 Pre-extinction diversity. Just before the KPG extinction event, the number of non-avian dinosaur species that existed globally has been estimated at between 628 and 1078. 281 It remains uncertain whether the diversity of dinosaurs was in gradual decline before the KPG extinction event, or whether dinosaurs were actually thriving prior to the extinction. Rock formations from the Maastrichtian epoch, which directly preceded the extinction, have been found to have lower diversity than the preceding Campanian epoch, which led to the prevailing view of a long-term decline in diversity. 275 276 282 However, these comparisons did not account either for varying preservation potential between rock units or for different extents of exploration and excavation. 274 In 1984, Dale Russell carried out an analysis to account for these biases and found no evidence of a decline. Wink with a frown. 283 Another analysis by David Fastovsky and colleagues in 2004 even showed that dinosaur diversity continually increased until the extinction. 284 But this analysis has been rebutted. 285 Since then, different approaches based on statistics and mathematical models have variously supported either a sudden extinction 274 281 286 or a gradual decline. 287 288 In Cretaceous trends in diversity may have varied between dinosaur lineages. It has been suggested that sauropods were not in decline while ornithischians and theropods were in decline. 289 290 The possibility that dinosaurs were the ancestors of birds was first suggested in 1868 by Thomas Henry Huxley. 241 After the work of Gerhard Heilmann in the early 20th century, the theory of birds as dinosaur descendants was abandoned in favor of the idea of them being descendants of generalized thecodonts, with the key piece of evidence being the supposed lack of clavicles in dinosaurs. 242 However, as later discoveries showed, clavicles or a single fused wishbone, which derived from Separate clavicles were not actually absent. Wink with a frown. 14. They had been found as early as 1924 in Oviraptor, but misidentified as an interclavicle. 243. In the 1970s, Ostrom revived the dinosaur bird theory. 244, which gained momentum in the coming decades with the advent of cladistic analysis. 245, and a great increase in the discovery of small theropods in early birds. 32. Of particular note have been the fossils of the G-hole biota, where a variety of theropods in early birds have been found, often with feathers of some type. 70. 14 birds share over 100 distinct anatomical features with theropod dinosaurs, which are now generally accepted to have been their closest ancient relatives. 246. They are most closely allied with Maniraptoran coelurosaurs. 14. A minority of scientists, most notably Alan Feducia and Larry Martin, have proposed other evolutionary paths, including revised versions of Heilmann's basal archosaur proposal. 247, or that Maniraptoran theropods are the ancestors of birds but themselves are not dinosaurs, only convergent with dinosaurs. 248,